Welcome back, everybody, for another deep dive. And, today we're going to be tackling a research article that is really making waves in the quantum physics world. I mean, get this. Scientists have discovered something they're calling quantum tornadoes. And no, it's not a scene out of Sharknado, although...
It's pretty wild, though.
It is pretty wild.
It definitely caught my eye as well. What's interesting here is that these tornadoes, they're not like the ones we're used to, right? They're not swirling through the air. Instead, we're talking about swirling formations of electrons, but get this, in another dimension.
Another dimension. All right, now you've got me hooked. So we're not talking about another universe or anything like that. What is this other dimension?
Yeah, so this dimension is called momentum space. And you can think of it this way. Instead of looking at where a hurricane is on a map, we're looking at a map of its energy and the direction it's moving.
So instead of seeing the hurricane, we're seeing where it's going and how strong it is.
That's a really good way to put it. You see momentum space. It's all about an electron's energy and direction, not its physical location. And this is actually the first time we've ever seen these electron vortices swirling around in this way.
So this is kind of a big deal then.
It's a huge deal. It's like opening up a new dimension in our understanding of how electrons behave and what this has potentially groundbreaking implications for a field called orbitronics.
Orbitronics, okay. Is that like electronics but with orbits?
Exactly. Think about it. Our current electronics rely on an electron's charge to transmit information. But what if we could use the electron's orbital motion, how it spins around the atom's nucleus to do work?
Okay, so instead of just using its electric charge, we're using its spin. That sounds incredibly efficient, I have to say.
And that's the potential of orbitronics, electronic devices that use significantly less energy. Imagine a world where your phone battery lasts for weeks, or computers run on a fraction of the power they need now. That's the kind of future this research hints at.
That sounds like a future I definitely want to be a part of. Okay, so how did scientists even manage to observe these tiny invisible tornadoes in the first place? It's not like they have tiny microscopes for the quantum world, right?
Well, they do have incredibly sophisticated tools. In this case, they use a technique called ARPES, which stands for angle-resolved photoemission spectroscopy. You can think of it as a powerful microscope that allows scientists to see the energy and momentum of electrons.
So they're not literally seeing the tornadoes, but rather their energy signature.
You got it. And to get the complete picture, they had to scan the material layer by layer, much like a CT scan creates a 3D image of your body. This allowed them to reconstruct the full three-dimensional structure of the quantum tornado. It's really a remarkable feat.
It is, but here's what I find even more remarkable. This wasn't some random lucky discovery. This was predicted, right? Like someone actually saw this coming.
You're absolutely right. 8 years ago, a physicist theorized that a quantum tornado could form in momentum space. He even described it as a smoke ring because of its swirling vortex shape. But back then, nobody knew how to actually observe it.
So a theory from 8 years ago just got proven science is amazing. I bet those physicists who predicted this are feeling pretty smug right now.
I'm sure there are a few "I told you so"s going around, but what makes this even more fascinating is how these tornadoes are formed.
Yeah.
It all comes down to something called orbital angular momentum.
Wait, are we talking about the momentum of the electrons as they spin around an atom's nucleus?
Yes. That circular motion creates the momentum that drives the formation of these larger tornado-like structures.
Yeah.
It's like a dance within a dance.
Wait, so we have electrons spinning around an atom's nucleus, and then those spinning electrons are also forming these larger tornado-like patterns. My brain is doing backflips right now.
It is mind-bending, isn't it? But understanding this complex dance is key to unlocking the potential of orbitronics.
Okay, so we've been talking about how these quantum tornadoes form and the material tantalum arsenide that makes them possible, but this is all happening on a microscopic scale. How do these tiny twisters translate into something that could actually impact our lives?
That's where things get really exciting. Remember,
Yeah.
we touched on orbitronics earlier. That's the potential game changer here. Imagine harnessing the orbital motion of electrons to create devices that are far more energy efficient than anything we have today.
So instead of our phones dying after a day, we could be talking about weeks on a single charge.
Exactly. Think about the implications for everything from smartphones and laptops to electric vehicles and even large-scale power grids. The potential for energy savings is enormous.
That sounds incredible, but if this technology is so promising, why haven't we seen any real-world applications yet? What's the holdup?
Well, it's important to remember that we're still in the very early stages of understanding this phenomenon. We've just observed these quantum tornadoes for the first time. Now, the real work begins figuring out how to control them, manipulate them, and integrate them into functional devices, it's a huge challenge.
So it's not just about finding these quantum tornadoes, it's about taming them, like training them to do our bidding.
In a way, yes, we need to figure out how to create them, reliably control their behavior, and harness their unique properties for specific applications.
So it's a bit like discovering a new species of animal. You can't just assume you can immediately domesticate it and teach it tricks.
That's a great analogy. There's a lot of fundamental research that needs to be done before we can even think about practical applications.
Okay, so we've got these tiny tornadoes swirling around tantalum arsenide. We need to figure out how to control them. Then we need to design devices that can actually utilize their properties. It seems like there are a lot of steps involved.
There are, and it's important to remember that scientific breakthroughs rarely happen overnight. This discovery is just the first step on a very long journey, but it's a journey that has the potential to lead to some truly revolutionary technologies.
Well, I'm definitely on board for this ride, but let's shift gears for a moment and talk about the people behind this discovery. This seems like a massive collaborative effort.
You're absolutely right. This wasn't the work of a single scientist toiling away in isolation. It was a global team effort involving researchers from multiple countries and disciplines.
So it was a real meeting of the minds.
Precisely, the lead researcher, Dr. Maximilian Ünzelmann, collaborated with physicists, material scientists, and experts in experimental techniques from all over the world.
It makes you realize that science is truly a global endeavor, and that some of the biggest breakthroughs happen when people from different backgrounds and expertise come together.
Exactly, and this discovery is a perfect example of that.
It also highlights how interconnected different fields of science can be. We started with the physics discovery, and now we're talking about potential applications in electronics, computing, and even environmental science.
That's what I find so fascinating about this research. It has the potential to impact so many different aspects of our lives, and we're only just beginning to scratch the surface of what's possible.
Speaking of scratching the surface, where can our listeners go to learn more about this research and delve deeper into the world of quantum tornadoes?
Well, the original research article is published in Physical Review X, but I realize that might be a bit dense for the casual reader.
Yeah, I think my physics knowledge is a bit rusty.
No worries. The Cluster of Excellence, ct.qmat. The group behind this research has a great website and social media presence. They share updates and insights on their work in a more accessible way.
Perfect. We'll be sure to include links to those resources in the show notes for anyone who wants to learn more. Now let's talk about the future. Where do you see this research going in the next few years? What are the big questions that still need to be answered?
One of the biggest challenges is going to be figuring out how to scale up this technology. Right now, we're observing these quantum tornadoes in very controlled laboratory settings. But to create practical devices, we need to be able to create and manipulate them on a much larger scale.
So it's like the difference between baking a cake at home and running a commercial bakery.
Exactly. We need to go from small-scale experiments to industrial-level production, and that's going to require a lot of innovation and ingenuity.
What about the applications themselves we've touched on? Electronics, quantum computing, data storage. Are there any other potential uses for these quantum tornadoes that are on the horizon?
One area that's particularly intriguing is quantum sensing. Because these quantum tornadoes are so sensitive to their environment, they could potentially be used to create highly sensitive detectors.
What kind of things could we detect with these quantum tornado sensors?
The possibilities are vast. We could be talking about detectors that can pick up minute changes in magnetic field's temperature, or even the presence of specific molecules. This could have applications in everything from medical imaging to environmental monitoring to material science.
So we could be talking about quantum tornado-powered sensors that are so sensitive they can detect things we've never been able to detect before.
Exactly. And that's just one example. And I think we're only just beginning to understand the full potential of these quantum tornadoes.
Yeah.
It's a truly exciting field to be watching.
We've covered some really mind-bending stuff today, from invisible tornadoes to tantalum arsenide to the very nature of reality itself.
It's been quite the journey.
It really has. And, it makes you think about all the things we still don't know about the universe. It's almost a little bit humbling, isn't it?
Oh, absolutely. It really puts things into perspective, doesn't it?
Yeah.
Here we are in the 21st century thinking we have it all figured out, and then along comes something like quantum tornadoes to remind us just how much more there is to discover.
It really makes you wonder what other mysteries are out there just waiting to be uncovered. I mean, what other strange and wonderful phenomena are lurking in the quantum realm?
That's what keeps me going as a scientist, that sense of wonder, that drive to explore the unknown. It's like we're standing on the shore of a vast ocean and we've only just dipped our toes in the water.
And who knows what incredible creatures we might find swimming in those depths.
Exactly. And that's what I find so exciting about this whole field of quantum physics. It's full of possibilities, things we can barely even imagine right now.
And it's discoveries like this one with the quantum tornadoes that inspire the next generation of scientists and engineers. I can just imagine some young kid hearing about this and thinking, wow, I want to study that. I want to be a part of uncovering these mysteries.
I hope so. We need more curious minds like that to keep pushing the boundaries of science and technology.
Well said. And for all our listeners out there who share that sense of curiosity, we encourage you to keep exploring, keep asking questions, and never stop learning.
Because the world is full of mysteries waiting to be unraveled. And who knows, maybe you'll be the one to make the next big discovery.
Maybe you'll be the one to discover a new type of quantum tornado or figure out how to harness their power to change the world.
The possibilities are endless.
That's a great note to end on. Thanks for joining us on this deep dive into the world of quantum tornadoes. We'll catch you next time for another fascinating exploration of the cutting edge of science and technology.